All right, let's jump right into a story that could seriously mark a turning point for the future of computing. IonQ just announced a breakthrough that's making huge waves in the quantum industry. And believe it or not, it all comes down to one single, incredibly important number. Here it is. 99.99%. Four nines. Now, I know, at first glance, that might not look like much. But in the wild world of quantum computing, that number, well, it represents a monumental achievement. It's a goal the entire industry has been chasing for decades. Yep, you heard that right. IonQ has officially set a new world record for how accurately a quantum computer can perform. They have absolutely shattered a critical barrier that was holding back the true potential of these amazing machines. So, what does this actually mean for us? Okay, so let's break this down. We're going to start by looking at what makes this world record so incredibly significant. Because this isn't just a small step forward, it's a genuine leap. And here's the kicker. IonQ is the very first, and so far, the only company to hit this 4 nines benchmark. For years, this level of accuracy has been like the industry's North Star, the ultimate proof that a quantum system is stable and precise enough for the next generation of computation. But, to really get why 4 nines is such a game changer, we need to talk about the biggest headache in quantum computing, the quantum error problem. The key metric everyone watches is called two-qubit gate fidelity. The easiest way to think about it is like a report card for a quantum computer. It's a single score that tells you how accurately it does its job. A higher score means fewer errors, and fewer errors means you can tackle way, way more complex problems. So for a long time, the gold standard was 3 nines, or 99.9% fidelity. That sounds pretty good, right? It works out to about 1 error for every 1,000 operations. But look at this jump to 4 nines. This isn't a small improvement, it's a massive 10-fold reduction in the error rate. Now it's just one mistake in every 10,000 operations. That brings us 10 times closer to the holy grail of fault-tolerant quantum computing. So here's the crucial part. Crossing this barrier has a staggering, almost unbelievable impact on performance. Let's take a look at just how big we're talking about. 10 billion times. No, that's not a typo. IonQ estimates that this single jump in accuracy delivers a 10 billion-fold performance increase over a system running at that old 99.9% standard. I mean, that is just a mind-boggling, game-changing number. So what does a 10 billion-x boost actually get you? Well, it unlocks a completely new tier of computational power. It means that researchers and customers can now run algorithms that are so incredibly complex, other systems just couldn't even attempt them. We're talking about solving problems that were, until right now, effectively impossible. Which, of course, brings up the obvious question, how on earth did IonQ do it? The secret sauce is a special technology they have called Electronic Qubit Control, or EQC for short. And this really is a whole new way of thinking. You see, the traditional way to control qubits involves these huge, complex, and super sensitive laser systems. IonQ's EQC technology, it just scraps all that. Instead, it uses precision electronics that are integrated right onto a standard semiconductor chip. This makes the whole system more stable, more compact, and, this is the big one, it's mass manufacturable. And this quote from Dr. Chris Balance really says it all. The fact that they achieved this record-breaking performance on chips that can be built in existing, standard factories is the key. This isn't some fragile experiment in a lab anymore. It's a clear, scalable path to building systems with millions of qubits. All right, let's wrap this all up. What does this huge breakthrough really mean for the future of the entire field and for IonQ's own plans? So, if you boil it all down, there are 3 huge takeaways here. First, that dramatic 10 billion times performance increase. Second, the ability to finally tackle those deeper, more complex algorithms for some serious breakthroughs. And third, it actually speeds up the race to market because with fewer errors, you just need fewer physical qubits to build a powerful, reliable system. And you can see exactly how this achievement plugs right into their roadmap. This 2025 breakthrough is the direct foundation for the 256-qubit systems they're aiming for in 2026, and it's what puts them on a much faster track to their goal of millions of qubits by 2030. This result from IonQ really feels like a watershed moment. It brings the dream of fault-tolerant quantum computers years closer to reality. And that leaves us with one very exciting and very important question to think about. Now that this power is being unlocked, what impossible problem should we solve first?